Okay, let's give this a shot. So, graphing inequalities on the Unit 6C, check your understanding. This one has that very distinctive slope-intercept form. Slope is -5/4, y-intercept is 2. So when I put a 0 in for x, I get a 2 out for the y, so I will mark that point. And when I then go down 5 and to the right 4, so 1, 2, 3, 4, 5, and to the right 1, 2, 3, 4. That point should be on there. Of course, I could have gone up 1, 2, 3, 4, 5, and to the left 1, 2, 3, 4. The points lining up that way in a negative slope is good. This has a less than symbol, not a less than or equal to, so I know that it's a dotted line that I want to make across here. So I'll try to line those things up and make myself a dotted line. Should have taken the time to get an actual ruler. Okay, got a dotted line, and then I got to decide where to shade this. I'm going to test the point 0, 0. So if I put 0 in for x and 0 in for y, I get 0 less than, this thing all goes to 0, 0 less than 2, which is true, which means this point should get shaded when I do the shading, which means I must be shading on this side of that line. So that's what that graph should look like. Okay, next one, not in slope-intercept form, but I could put it into slope-intercept form. I'll do that work up here. I'm going to subtract 5x from both sides, and that'll give me a -5x plus 4, and then I'll divide everything by -2, and that will give me a y. This will be a 5/2 x and a -2. Now, I know that the result of that is going to switch this, but that's not necessarily something you need to remember at this point. In fact, we're just going to treat it as an equal sign, so we get the line in the right place. Y-intercept, again, if I put a 0 in for x, I get a -2 out for y. And then a slope of 5/2 is up 1, 2, 3, 4, 5, and over 2, up 1, 2, 3, 4, 5, and over 2, or down 1, 2, 3, 4, 5, and to the left 2 would line that up as well. Now this one, it has the equal to part, so the points on the line are good answers. So I'm going to make a solid line to indicate that. Doesn't go through 0, 0, so I'm going to test with 0, 0 again in the original problem. So 0 for x, I get a 0 minus 0, I get 0 is greater than or equal to 4. But 0 is definitely not greater than or equal to 4. So when I shade, I need to make sure that I don't cover up 0, 0, which means my shading must be on this side. Okay. Now, at this point, this equation or inequality is given to me in point-slope form. Point-slope form looks like y minus y1 equals m times x minus x1. And so if I was going to match that up here, the m would be -3. The x1 would have to be a -1 because it's got a built-in subtraction, but it's showing as addition, so minus the negative is why it shows up there, and the y is 2. So if I go to -1, 2, that should be one point that is on this graph. And then I have a slope of -3, which is either down 1, 2, 3, and to the right 1. Do that again, down 1, 2, 3, and to the right 1. Or I could go up 1, 2, 3, and to the left 1. Okay. See those lining up? I don't see the equal to part in there, so I need to have a dotted line. Try to line these points up carefully here and make a dotted line in there. Comes pretty close to 0, 0. I don't always have to use 0, 0. It's nice to use that. This time, let me go ahead. I'm going to use 0, 2. Because if I use 0, 2 as my test point, then I'm going to get 2 minus 2 is greater than negative 3 times 0 plus 1, so negative 3 times 1. That's 0 is bigger than negative 3, which is true. And so that means that 0, 0, or this test point at 0, 2 should get covered up when I shade. And so I'm going to shade this direction on that. Okay. So that's the basic part of it. I think I'll split this into 3 videos so no one of them gets too long.